Hello guys, welcome to a new episode. So last time we realized that there is a small error in our straight flush. In a straight, apparently the ace can count as obviously an ace or a 1. So our system looks for the number 5 and the number 1. Only the number 5. And when it finds it, subtracts 5 to figure out what the highest number in that straight is. So in our case, what we had was a flush. What we had was a straight in the lowest position would be up to this point here, which I believe was a 6. So this says yes, 6 is the highest point, the number 6. We can have one up to 5 in a very, very specific case that I would like to look for. In this case, pretty much, if we index our array, it requires some very, very specific things to be true. First, the first element of the array and the last element of the array. So the last element, which I will draw up here, and the first element, which I'll draw up here. So first, I believe element 2 is first and last. Now first should be 1 in this case, and last should be 5. Perfect. If the sum of those two, is equal to 5. So I'm gonna steal that 5 from right there. If the sum is equal to 5, then we are in a very special case where a true or false system. So if it is equal to 5, then set the win to 5. The straight is all the way up to 5. Otherwise, well, nothing changes. So instead of all this, I'm just going to do another one here and call it 5. So there we go. And this, instead of being 0, will be whatever that value is, and that will propagate out here. Let's go ahead and check this. So this is 6, that's right. We have an ace. 2, 3, 4, okay. We need to check if this is, not just if it's equal to 5, we need to check if the sum of those two is greater or equal to 5. So in this case it would be 6. And that means that in the event that we don't have this number 6 here, when I run this, it should also find it till 5 as a backup, because 6 is higher. So this is a last resort which gets processed. And there we go. This is how we figure out if there is a straight or not. I'm going to condense this and get back to you guys. Alright guys, so here we are. One small addition I would like to do here is I would like to actually put the entire straight as a system by itself. And the reason I would like to do that is because if we really think about it, a straight needs 5 cards obviously, and a flush needs 5 cards. Now if a straight and a flush both occur, the only possible way that that is true is if they are indeed within the same loop. So that's why I would like to set it as a system by itself, where if there is a straight, then I would like it to take that straight and basically tell me about it. So tell me, yes, I found a straight, and just tell me where that straight was found. Alright, so what I will do is we need to set up a stop condition for this. Basically, if it finds one, I would like it to stop. And if it finds one, that means that either one of two things happened. Either this one up here found it, or this one down here did. So if one of these found it, then that's perfect. Or the alternative way of looking at this, if this is not 0. But to keep this in a condensed format, as condensed as I can make it, I will put it here and add an OR. So if either one of these is 0, then the entire thing will be stopped, and this will tell me basically if it found, well, it will tell me where it found its straight. I can immediately assume, oh, I just realized something, guys, I'm sorry. So what I just realized is that this straight that is found up here may not be the flush straight. So there is a flush straight, and then there is a straight that could be any non-flush number. So I actually made a mistake there. The way to correct this is... No, actually I was right, because technically if there is a straight and no flush, that means it's not really a straight flush. You can have a flush that is not straight, but you cannot have a straight. You can have a flush and a straight, can you not? Yes, you can. You definitely can. Because a straight does not need to match the flush. 2, 3, 4, 5. This here assumes I do have a flush. Let me run this real quick. 2, 3, 4, 5, 7. Let's run this. 2, 3, 4, 5, 6. Now I do have a flush. 2, 3, 4, 5, 6 right here. And I do have a flush, and I do have a straight. So yes, we cannot do that. Sorry, guys. So apparently, what I thought could work does not work. So let me just, I'm gonna go ahead and return everything the way it was and get back to you guys. So I will be right back. What I'm thinking of now, before I go, is that how do we process a normal flush or not flush? I believe how we process a normal straight, I'm sorry. We can set up a system that would basically first detect the flush, then use the detected flush, if a flush were indeed detected, to try to find a straight. If a straight is found, then everything is good. So I'm going to do that, so that we don't have to run the flush twice in 2 different places. So basically, if this is true, again, I'd like another system here, which will either give us this sequence, or it will basically give us the sequence of nothingness. What does the sequence of nothingness look like? Well, it will be an array. So I'm going to build an array, and this array can be pretty much any number I want, and obviously I will pick the number 0. There we go. So now with it being the number 0, there's no way that a flush could be found. Let's go ahead and run this through here. There we go, and this is my flush detector. Create an indicator of it. Yes, no, yes, no, yes, no. Yes or no, guys? I'm not sure. I think I did something wrong. Yeah, I did do something wrong. Let us remove the for loop. Whoa. Epic wrongness going on right now. So we have an array here. Okay, it seems like everything works now. No. Oh, the stop condition. The stop condition is no longer wired. That was the mistake. I should have paid more attention to figure that out. So we let us re-add the stop condition. But the stop condition was originally added because we did not know if we needed it or not. In our new scenario, if we remove the index from here and remove the for loop from there, we no longer need to stop, and everything is back to normal. Perfect. These little tricky things. So now we can actually go ahead and test this, and hopefully it will work. Let's see. So where's our test? This is the F2, which is determining whether the flush we have is a straight or not. In this case it is not. If I convert this back to spades, this becomes a 6. So now we have a flush to 6. So here we have straight, flush, 0 is no, n is high. So basically, to which number you got to, I have a flush to the number 6. This is exciting. Now, if we are going to try to find a normal flush, we would need to use this one right here. So how do we do this? Very simple. If I go ahead and build an array out of this flush and this flush, and then if I were to run it through a for loop and then connect it up here, then I would get 2 answers, where if I index these answers, the first one should give me the straight flush, while the second one should give me a normal straight. This should be whether there is or is not a normal straight. And there should be a straight in here. Obviously there's a straight to 6, but there might be a straight to 7. There we go. Let's run this, and it says there's a straight to 7. This is my straight flush. This is my normal straight, where 0 is nothing and n is high. So if I did not have this, then I would only have, I still have a straight, I still have a straight. Let's convert this to a heart as well. There we go. There's no flush. If there's no flush, there cannot be a straight flush. In this case, it says there is a straight flush. How could there be a straight flush? Let's see. Straight flush, no, n is high. This says there is one up to 5, and I want this to say 0. How does this say that there is one up to 5? Because it is running a check on the array, and the array, let's see what the array coming out of here says. This will be our determinant right here. This is an array with a single 0. How does an array with a single 0 produce the number 5? So we take this array, comes in here once. Is this equal to 0? Yes, so this is 0. So this is only one number, 0. Search for the number 5. If you find it, perfect. If not, not. Get the number 0 plus the number 1. Okay, let us create a constant, run this only once. Show me what is coming out of here. Array 10. Array 10 is just a bunch of zeros. So what is the sum of those two? Create an indicator. the sum of those two is 0. Now, if the sum is 0, meaning that this is, let's run an indicator. Aha! How does is 5 greater? Whoa, what? No. If 5 is greater or equal to this. There we go. Run a test on that. And perfect. Now it works again. If we convert this back to spades, we have a flush but not a straight flush. 6, 5, 4, 3, spades. Now we have 1 till 6. Spades. Now we have 1 till 7. Perfect. And there's no, it's funny how this says there's no straight. How's this not, oh, it's not detecting, it's just not running. That makes sense. Let's run it again. Should give us the same answer. Beautiful. Beautiful. So now we have our straight, straight flush, and flush. The flush gives us the type. The straight flush has the type of the flush. Alright, let us end this episode here and we'll continue next time. Bye.